In this video we're going to talk about using the law of sines, which is a useful tool for finding the side lengths and angle measures of any triangle, not just right triangles. So we're going to see how the trigonometry that we've learned in the past can apply to any triangle now. So the law of sines says that if we have some triangle, let's call it ABC, and this triangle has angles A, B, and C obviously, and the sides A and little b and little c, these are the side lengths that are opposite of their angles A, B, and C. And if we have that set up, then this is what we end up with. We can have the ratio of the sine of A over side length A is equal to the sine of angle B over side length B, which is also equal to the sine of C over C. Now this is three fractions here. Usually we just use two at a time, as we'll see. And so it makes a nice proportion that if we know three of these items, then we can solve for the fourth one. Let's see how it works here. So here we have a triangle, and we know that A is 40 degrees. Alright, so let's say that A is 40 degrees. We know that angle B is 60 degrees. And we know that side A is 10 centimeters. Alright, so with that there, we know that the sine of angle A over A, side A, is equal to the sine of angle B over side B. Alright, so A in this case is 40 degrees, so we have the sine of 40 over 10 centimeters is equal to the sine of 60 degrees over B. And we want to find out what B is. Now let's back up a step. The directions here are to solve the triangle. And what that means is we want to find all the missing angles and all the missing sides. Alright? So, okay, so we know that the sine of 40, that's just some decimal value. The sine of 60, that's just some decimal value. Alright, so we could calculate this out right now, but we're going to leave it alone because the decimal values just get messy. So let's go ahead and cross multiply. So we have b times the sine of 40, which is equal to 10 times the sine of 60. Whatever the sine of 60 is. Once again, sine of 40 is just some decimal value. So we have b times some decimal value. So we want to solve this equation, so we divide by the sine of 40. Divide by the sine of 40. And these cancel. And that leaves us with b is equal to 10 times the sine of 60 divided by the sine of 40. And we can go to our calculator now, and we can punch that all into our calculator. Make sure you use your parentheses correctly and all that. And that's going to give us 13.47. Alright, so we found out what B is. Now, we want to find what C is. Now, angle C here, we can find. Let's go ahead and do that. Well, we know the angles in a triangle add up to 180. So, we know that 40 plus 60 plus the measure of angle C is 180. And so subtracting 40 and 60 from both sides, we get the measure of angle C is 80. Alright? So we found C. We just found B a second ago here. So this is 80 degrees. Alright. Lastly, we need to find out what side C is. So now we can go back and we can use our law of sines again. So we know that the sine, let's use A again here. Okay, so we could use what we just found there, the 13.47, but it's best to go back here and use the 40 and the 10 that we had from the beginning. So let's use those because we had those, we know those for sure. Alright, and so we're going to have the sine of 40 over its opposite side is equal to the sine of 80 now over c. Alright, and cross multiplying gives us c sine 40 equals 10 sine 80. And then dividing both sides by the sine of 40 to get rid of that, we end up with c is 10 times the sine of 80 all over the sine of 40, which, going to our calculator now, we get approximation here, and that gives us about 15.32. And so now we have solved the triangle. We found all the missing sides and all the missing angles. So that's how we use it, the law of sines, to find missing sides. Next, we'll see how we can use it to find missing angles. Alright, in this problem we want to solve the triangle again, but we've got some different information here. In this problem, we know angle A is 35 degrees, and side A is 10, and side B is 9. Alright, and so we know a side, and an angle. And so the situation we have here we can call side, angle, because we know those pieces of information. The angle is not between the two sides. Notice that. Alright, well, we can use the law of sines here. Let's go ahead and try this out. We know the sine of 35, which is our A value, over side A, which is, let's go back, we know what that is. That is 10 equals the sine of, well, let's start with B, because we know side B, so let's look for that angle across there. We'll come back for C later. So we have the sine of B all over 9. Alright, now we want to get the sine of B all by itself, so let's multiply by 9 on both sides here. And that will give us 9 times the sine of 35 all over 10 equals the sine of B. Alright. Going to our calculator and plugging in 9 sine 35 over 10, we find out that the sine of B is about 0.5162. Now we're looking for an angle, so remember, to find an angle, if we know the ratio, we want to find the angle, we got to go backwards, kind of go in reverse here, so we're using the inverse sine. So we're going to use the inverse sine here, the inverse sine of 0.5162. Alright, the inverse sine there, and we plug that in. Plugging this into our calculator, we get 31.08 degrees. We'll leave some accuracy here. About 31 degrees. Alright. So, we've got, let's try that again. We've got this 31.08 degrees. Okay. basically 31 degrees. Now notice, by the way, that this drawing is not drawn to scale. This is just a model. When you're doing these problems, it's useful to sketch a sample triangle just to kind of get a reference of where all your angles are. But notice here, this 10 is definitely not bigger than this 9. So anyways, but we have 31.08 here. Now, even though the drawing doesn't look that way, we have that. Okay. Now, when we look at this here, when we think about our unit circle, we got to take a moment. We got to think about this. So if we go to our unit circle, we know that the sine is the y value of the points on this unit circle. Okay. So in our unit circle, if we have a sine is 0.5162. Well, that's the y value. Okay, so that means we have a y value that is at 0.5, about 0.5162. So somewhere right about here. Okay, and so that's going to be this angle right here, which is about 31.08 degrees. Well, is there any other point on this unit circle that has a y value of 0.5162? This one right here does. This is some x value we don't know right now, and the y value is 0.5162. Any other points on the unit circle that have that y value? Well, sure. There's one right over here. That angle right there has a y value of 0.5162. All right? So, alright, so that also does, and what is that angle? That angle right here, that is 180 minus 31.08. And if we subtract that up, we get 149 degrees. Actually 48.92, but we can round that off. Okay, in fact, let's go ahead and just round this off. Directions will usually tell us here, but we don't have specifics, so let's just call this 31. That's close enough. That's pretty close. Okay, so we've got 31 and we've got 139. Okay, alright, 149. Alright, so we've got 149. So that means that maybe 149 is another possibility. Well, if 149 is another possibility, we have what we call the ambiguous case here, or the indeterminate is another word that's used for it sometimes. Well, let me put a question mark there. Could B be equal to 149? Well, if that was the case, then we are saying here, we're saying that A is 35 and B is 149. Well, if you add those two angles to try to find out what C is, we get 149 plus 35, and that's going to give us 184, right? But a triangle can only have 180 degrees in it, so we've got a problem here. So we don't have enough room for C. So this we have to throw out. This is not possible. Not a possible option, we can say. Or angle. Okay. Not a possible angle. So, alright. So that means that the only possibility for B is 31. Alright, let's finish this problem off. And in another video, we'll see what happens when this is a possible. Now, if we check this out and we find out that this is less than 149 degrees, maybe we got some other smaller angle, then we'd have to find two possible triangles, and we'll look at that on a different video. That for the indeterminate case. All right. So right now, we only have one possibility for B. It's 31 degrees. We got that. C, we can find out that 35 plus 31 plus the measure of angle C is 180. So subtracting 35 and 31 from both sides, or 66, gives us 134 degrees for angle C. Again, our drawing is not drawn to scale, so we have to just be okay with that. All right, just a model. So let's go ahead and find C. We've got the sine of 134 over C is equal to, and let's go back to the original one that we had from the beginning, sine of 35 over 10. All right. Cross multiplying and dividing will give us that C is equal to 10 sine 134 over sine of 35. And using our calculator, we find out that this is 12.5 approximately. So we've solved the triangle by using the law of sine once, checking to see if there's another possible angle. Sometimes there is, sometimes there's not. In this case, there's only one possibility. Using the fact that the angles add up to 180 to get the missing angle, and then using the law of sines one more time to find the third side. Alright, so we can now find missing angles and missing sides with the law of sines. So good luck, and we will talk again about these indeterminate cases.